Okay, I'm going to have a look at this memorization sort of cheat sheet because I'm not a fan of them, and I'm going to talk through it and sort of show you what you can learn through just knowing maths, essentially. So I might be a little sarcastic in this, but forgive me. Okay, all of this is in the formula booklet, literally here. Let's find it. So you can memorize it if you want, but essentially it's all here. You can see the first three. But when you practice questions, you're literally going to burn it into your brain. So yeah, you're fine. Double angle formulas here. Well, again, you can memorize them, but 2x, it's literally sine x plus x, rectangular terms, year 7, remember those lessons? And you should write it out. Sine x, I messed up, cos x plus cos x, sine x, and guess what? You can group them up like terms. So there you are. You get your 2 sine x cos x. So yeah, just remember x plus x. Easy. Same here. Cos of 2x. Guess what? It's x plus x. So there we are. X plus x. And you get cos x, which is cos squared x. And we're going to do the inverse. So minus sine squared x. Okay. Again, you've got to memorize that just by default by doing questions. That's fine. I personally would not even bother memorizing these because I would literally memorize the top one there. And then we know, really important, the one here, really important. We're going to use this all the time. So that is key. Again, it's one of the first things you learn. It's simple. So you are technically memorizing it, but it comes up all the time. So what we know from this is cos squared x equals 1 minus sine squared x. And likewise, sine squared x is 1 take away cos squared x. So when we're here, it also equals, what I'll do, I'll make this a bit neater. So let's clean that up a bit. So it equals cos squared x take away, well, sine squared x is 1 take away cos squared x. And that gets us what we had. Cos squared x take away cos squared x is 2 cos squared x take away 1. Easy. And likewise, we can change the cos squared x to 1 take away sine squared x. Take away sine squared x, and you've guessed it, 1 take away 2 sine squared x. So there we are. Again, you can memorize them if you want, but that's taking me, 30 seconds, there and there, done. Again, come from that one, and we've taken it from up here. Lovely. Okay, this one, literally in the formula booklet. Why would you memorize it? It's there. X plus x. And you can put them in there yourself. Again, if you can't do that, maybe A-level's not for you. Right, what do I want to do next? Let's go up here. I would never memorize these. Why even waste your brain energy? So let's go back. Right, let's delete these here. Let's have a look. Right, this, lovely. Well, why don't we, firstly, let's divide everything by sine squared. Oop, that's too big. So sine squared x over sine squared x plus cos squared x over sine squared x equals 1 over sine squared x. There we are. Well, sine squared x over sine squared x, that is 1. Ooh. Yeah, fine, I'm gonna. So that becomes a 1. Now, cos squared x over sine squared x is the reciprocal of sine over cos, so it's going to be cot squared x, and that's going to equal 1 over sine is sec, yeah, sec squared x. No, 1 over sine, cosec, silly, cosec. There we are. Again, look, okay, I made a slight error, but look, that's taking me, 2 seconds to fix it? Life goes on. Right, so this time, this is where we divided it by sine squared x. I think that one is hidden here, yeah. So I've done that one there, lovely. So let's divide it all by cos squared x now. Let's see what happens. So sine squared x over cos squared x plus cos squared x over cos squared x equals 1 over cos squared x. Lovely. Well, sine over cos is tan, so sine squared over cos squared is tan. squared x. Cos squared over cos squared. Sorry, cos squared x over cos squared x is 1. Lovely. And 1 over cos squared x is sec squared x. Lovely. Done. Really simple there. Awesome. Again, I'll just recap. Let's see them in here. Your reciprocals. Well, sine x. 1 over sine x is cosec x. So we've got cos x, so 1 over cos x is sec x. Tan x, 1 over tan x is cot x. And if you're ever panicking, you literally just saw me kind of forget it there. Let's get a highlight to it. And I like this. So the S, oh God, the S lines up with the S. The C lines up with the C, and the T lines up with the cot. Lovely, simple. So there we are. Those are your reciprocals of your sine, cos, and tan. Right, let's have a look at the formula booklet here. I want to look at this one here, because in the formula booklet, can you integrate tan squared x? You can't, but we can integrate sec squared x. I've seen this come up all the time. If we want to integrate tan squared x with respect to x, we have to rewrite it as sec squared x take away 1 dx. And then we go back to the formula booklet, integrate sec squared x, that becomes tan of x plus x plus c. Ooh. There we are, easy. So again, we don't have to memorize this. We just need to know where it comes from. Here, enough exam practice. We know we have to rewrite it in this form, and boom, in the formula booklet, and we're done. Okay. I've never ever seen these come up. Let's see, are they in the formula booklet? We can probably just get them from the double angle formula. Yeah, probably here. Yeah, fine. I've done enough exam practice in my life. I've never seen this come up. I could be wrong, but I've never. So this is rearranged, so it's probably come from here somewhere. But I'm not really bothered because I've never seen it come up in a question. Okay. Here. Yeah, that's his basic functions. We know when we literally learn this at GCSE, sketch a sine graph, and the cos graph is 90 degrees to the left. So we literally learn this. 90 minus x, that's fine. We can rewrite it as x plus 90. Yeah, so we can even move it 90 to the left. Can we go to the right? I already... yeah, fine. It's the same thing, isn't it? Again, sweet, but you got to calculate in the exam. I don't really see why you're going to lose time over that. Sine, let me have a think. X plus 90, that would equal cos x. Yeah, because cos x is 90 to the left. Yeah, it works for me. It's probably just backwards. No problem there. Yeah, cool. Let's move on. Again, you got a calculator. Right, yeah, I guess you can memorize this. Fine, it's pretty standard. Again, do questions, you learn that. This is in the formula booklet, so why memorize it? Formula booklet. That's in the, this is in the formula booklet, so why memorize it? It's there. This is silly. Let's literally rewrite this as dy over dx equals dy over dt times dt over dx. Cool. I don't do uni maths. Look, they cancel out. Life is good. Dy over dx equals dy over dx. And cool, reciprocal of multiplying. That's year 7 fractions. Fine, done. You can literally flip that yourself and divide it. Just do questions. I don't know what this is. I'm not familiar with it. So, yeah, substitute, change limits. Yeah, it makes sense. Just do questions and learn maths. This is cool. This is the same thing. They cancel out. So you're literally doing the integral or whatever your function is in terms of dx. But you probably have t in there somewhere. So write dt over dx. And then you find the reciprocal, which is here, and you're good to go. I have no idea what this is talking about, so probably makes sense if I do a question. What else can I see? I'm going to come back to this in a moment. Yeah, this is just basic year 7 fractions. Cool. X minus 1, x over x minus 1 over x. Yeah, wow, that's cool. Year 7 fractions, same here. Cool. If you can't spot that, maybe they'll do A levels. Right. Is this just highlighting the first chain rule, what partial fractions look like? Fine. Wow, algebraic division, cool. I think which is highlighting that seems a waste of time. Right, and this is cool. Yeah, this is just how many of these are in the formula booklet. Well, the first ones are fine. This is a nice little way you can look at it. Sine of x, the derivative is cos of x, the derivative is negative sine of x, and the derivative is minus cos of x. The integrals, I think, will go the other way round. That makes sense. Yep. So I wouldn't even bother. I would just do that there. What we doing? Dy over dx. Are they in the formula booklet? Let's have a look. Tan of x is there. That goes to sec x. Fine. So that's in the formula booklet. Cot of x, is that in the formula booklet? It is in the formula booklet. So that's in the formula booklet. Sec of x is in the formula booklet. So why are we memorising this? Cosec of x is in the formula booklet. Right, ln of x, that you have to memorise, but you literally just do questions and learn that. That makes logical sense to me because we can integrate x squared. We know that. You're going to get 1/3 x cubed. But we can't integrate -1 because if we add it, it's 0, doesn't work. So yeah, that's something we learned, but that's basic year 12 maths. Basics here. And yeah, this one here, why learn it? So there's literally, I found it before this exam. Don't learn that, literally learn the maths. So you literally could get an exam question that asks you to prove this. So learn how to prove it, and then you are good to go. So let's do the proof. Y equals a to the x. Take the natural log of both sides. A to the x, and then we can say e to the power of natural log a to the x equals y. I can rewrite that as x times natural log a equals y. So dy over dx, we take the derivative of the power, which is natural log a, times itself, it's literally in the formula booklet up there. Great, and then what we can see here is that it's literally y, so dy over dx is natural log a times y, which is a to the x, and we're done. Cool. Easy. Done.